Today, day 2. Steps are the same. There's 2 number 2s. It's a typo. So this should be step 3, and this should be step 4. Just a typo. Okay? I haven't changed any steps, but there's going to be some wrinkles, differences from last week. Majority of it will be the same as what we did at the end of last week. But there are a few wrinkles that I'm going to show you that might help. Okay? A few things that might help. Might make the problems easier. Okay, so first thing. Solve. Check for extraneous solutions. Well, the first thing we did last week is we didn't even look. I'm focused on the side where the plus is or the minus is, right? I'm not even looking on the other side. My focus is right here, right? This is what you guys did last week. Okay? I need a common denominator, right? Well, 1. 1 is just a 1. So if I was to do a factor tree for 1, it would just be 1 times 1. So it's broken down, it's factored. X plus 5 is a binomial, right? So there is no GCF besides 1, and it's not difference of squares. So actually that one's factored too. So then I say, what's missing? What's missing, what's needed, right? Well, this guy over here needs an X plus 5, right? The other guy, it's technically already got a 1, right? The 1's right. You can do that if you want, but you don't need to. Okay? And then we say common denominator, X plus 5. On top, I have a 1 parentheses X plus 5 plus 7 distribute. Distribute the top. It's not going to change anything on this problem. It will in the future, but not on this problem. X plus 5 plus 7. Common denominator is right there. Then I have some like terms. Okay, I'm going to stop right there for a second. So I have, that side's done, right? It's 2 binomials. I've got a binomial here and a binomial here, right? Now I'm going to bring down the other one. Negative x, x plus 5. Right? That's what I did last week. So far I haven't done anything new. Here's where the new stuff will come in. And it's not really new. What did we do here after we got this? What were our steps? Cross multiply, right? You can do that. That'll work. That will work. You can do that. But on this, I notice I have a lot of x's. And if I cross multiply, I'm going to have to do, it's a lot of stuff. So I'm going to give you another tool to use. This always works. What do you notice about both fractions? They have the same denominator, right? They have the same denominator. It's exactly the same. So let me ask you about this one. There's an example on the board too, but let me exactly. If I had this one, and that part got smudged, and I can't see it. Let's say the question mark was smudged, and you couldn't see that number. I can't really make out that. What does that number have to be? There's no other way it could be anything else, right? It has to be. If the bottoms are exactly the same, the top has to be exactly the same. It has to be. So we're going to use that reasoning for this guy. If the bottoms are exactly the same, that means the tops have to be exactly the same. So what I'm going to do is I'm going to focus on the top here. Instead of cross multiplying, I'm going to do this. Because I don't have to worry about the bottom anymore. It's already the same. I'm just trying to focus on the top. What was the top? So from now on, I'm just going to focus on the top. Once I get the bottoms equal, now I'm focused on the top. It's a little less difficult than having to do cross multiplication. Solve for x. Well, get x on one side. Negative 2x. Because each of them was a -1, right? And +1. There were ones in there. Divide by -2. You get one answer, -6. Okay, without having to cross multiply. So now the only other step is to see if -6 is extraneous, to see if it's an okay answer or if it's extraneous, right? Well, if I plug in -6 here, am I going to get a 0? No, I'm going to get a -1. That's okay then. One box, -6, enter twice, green check. Okay. What's that? Nope, just once. Hit enter twice. You know, like on Delta Math, you have to hit it, and it says, "Are you sure you want this as your answer?" Yeah, that's what I mean. No. That's what I mean. Yeah. You get the same answer. You get the same answer. If you were to cross multiply, you would get the same answer. So let's say this is a test and you forget about this and you cross multiply, you will get the same answer. And you would still have to check, yeah. You might get another answer, but that answer would probably be extraneous. So you would end up only with one answer, -6, yeah. Absolutely. So do I have to use this method? No, you could use cross multiplication, but I think you guys are going to find today that this is probably easier to use than cross multiplication. Okay. All right, so let's go to B. Turn it over. Let's go to B now. Okay, so -6 doesn't have a bottom, so the bottom's always 1, right? Same thing. We have a 1 on the bottom, and I have an x minus 6 on the bottom. They're both factored, right? 1 can only be 1. If I do a factor tree for 1, it's just going to be 1. X minus 6 doesn't have a GCF, is it difference of squares, so that one's done. So that means the first guy is going to need an x minus 6. So the common denominator is x minus 6. Okay, so let me write down what I got on top. I got a -6, parentheses, x minus 6, and then minus 6. Distributive property? -6x plus 36 minus 6. The combine like terms, yeah. Combine like terms, you get negative or positive 30. So negative 6x plus 30 over x minus 6. Okay, so bring down what I haven't used. Well, look at that. They both have a common denominator already. You can do cross multiplication. That works. Do if you want to do it. But I think it's going to be a lot easier just to use our method we used last time, which was if the bottoms are the same, that means the tops have to be exactly the same as well. So I get negative 6x plus 30 equals minus or negative x. Solve for x. So you're going to get positive 5x. You get one answer, positive 6. Okay. Now, is that a valid answer, or is it going to be nope? It's extraneous, right? Because if I plug in a 6 there, what do I get? 0. So I get one answer, and that one doesn't work. So on Delta Math, what do I put? Empty box. You put empty box because the only answer that I had didn't work. No, because then 0 is an answer. 0 is a number. So if you put 0, it'll think, oh, you think 0 is an answer. We don't want that. Give me 1 second. For this guy, same thing. 2 doesn't have a denominator, so give it a 1. Common denominators. 1 and x minus 10. X minus 10 is already factored, doesn't have a GCF. Is in difference of squares. So I get x minus 10 as the common denominator, and then I get 2x minus 10 minus 3x. Okay, distribute 2. I get 2x minus 20 minus 3x. Yeah, Lana?
If we aren't gonna, if we aren't supposed to mess with, oh, never mind.
Yeah, okay. So we get negative 1x minus 20 over x minus 10.
Doesn't matter if you have to put the 1.
No, it doesn't. You could put negative x. Negative x is okay. I always put the negative 1 just, I don't know. That's just what I do, but you don't have to. Okay, so bring down x. Well, here, that's my question here. So I brought down the x. What is the denominator for x? 1, right? Well, we can't use our little trick we used in the last 2 problems because they don't have common denominators, right? So we have 2 options. Cross multiply. That works. Since I showed you that, I'm going to show you how to use that method, but you're going to tweak it a little bit. Cross multiplication works. But I'm going to show you another method. Well, if they have common denominators, I can set the tops equal to each other. What does this guy need right here? An x minus 10, right? So let's give it an x minus 10 multiplication wise. In order for me to do that, what else do I have to do? I can do that. So now they have common denominators.
Couldn't we just put an x minus 10 since if you really, or does the one have to be there?
The one doesn't have to be there. Okay. Here we go. So we get negative 1x minus 20 equals x minus 10. Okay. Distribute. Okay. This one has an x squared. So it's either going to be a binomial or a trinomial. So our first step is always going to be set it equal to 0. So let's set it equal to 0. So I'm going to add 1x to both sides. I get negative 9x, and then I'm going to add 20 to both sides. Okay, so now it's a trinomial, right? Okay, to solve it, we have steps. Set it equal to 0, done. GCF, well, besides 1, it doesn't have a GCF, so let's do ABC. One minus 9, positive 20. Positive 20 minus 9, negative 9. So the two numbers that multiply to be 20, 5 and 4, both of them got to be negative. Good. Okay, so I'm going to do the box now. X squared minus 5x minus 4x plus 20. Okay. Last step to solve it, separate and solve. Okay, so I get two answers, positive 5 and positive 4. My last step is to see if they're valid answers or if I'm not going to include them. I go back to the original. The only thing that can't happen on the bottom is if it's a positive 10. If it was a positive 10, that would make a 0. It's not. I have a 5 and I have a 4. You're okay. Two answers. Okay. Okay. 2 more problems. We're going to do 1 more problem in your notes and we'll be done. So these 2 are a little, I don't want to say different, but they just, there's things that come up here that we haven't seen yet. Okay. Here we go. First problem. Same thing, right? We got x plus x minus 2 and an x. Those are our common our denominators. We need a common denominator. Mhm. We can't use add and like look at all the problems. I've never used adding and subtracting, right? I've always used multiplication. Like that's like saying like this, watch. That's a great question because sometimes I ask people, so if I have this, oops. Common denominator, what's the common denominator for these 2 guys? Not 2. 8, right? Well, can I just add 6? Can I do that? No, I can't do that, right? I have to use multiplication. Same thing with these guys here. I can't just say, oh, subtract 2. Doesn't work that way. It'd be nice if it did, but it doesn't. I have to use multiplication. Okay? So, common denominator, this guy needs an x, and this guy needs an x. Because they're both factored, so. Okay, so on top, I get x times x, x squared. And then plus 9 parentheses x minus 2. Okay. Distributive property.
We don't have to distribute that x, right?
No, the denominator we don't really have to mess with. Bring down what I haven't used. Again, cross multiplication will work. It will work. It's just going to be long. And I don't want to have to do all of that. So is there a way I can make these 2 denominators the same? Include an x, right? It's already a binomial. I got that. Just give it an x, multiply x. Okay. Equals negative x to the 2nd power. Okay. It's got x squared, so that means these are all 1s. All right. So get everything on the same side. That means I'm going to have 2x squared plus 9x minus 18. It's been a while since we saw a be anything but 1. We saw a lot of these last semester, but I don't think we've seen too many this semester. So this is where it's not really a new thing, but it's just something you haven't seen in a while. Trinomial. No GCF?
Would the A still be a 1?
No, the A is going to be a 2 now. Yeah, A is going to be 2 now. That's one of the differences on this problem. A is 2, B is 9, C is negative 18.
So the top would be negative 18 times 2.
There you go. A times C, negative 36, not negative 18. The only time that works is when A is 1.
1.
So what do you get? So add up to be 9, multiply to be negative 36. It's going to be 12 and negative 3. $12x minus 3x. Okay, so one of them has to be a 2, one of them has to be a 1. I think 2 is going to be over here. It's going to make a plus 6 and a minus 3. Okay, separate and solve. Add 3 to both sides. Divide by 2. I get a fraction, it's okay. Fractions are okay as long as you reduce them.
The fraction can be reduced to 1/2, right?
Say it again.
The fraction can be reduced to 1/2.
It can't be reduced. It can be changed to 1.5. But I would leave it that way because sometimes when you change on Delta Math, sometimes when you change them to decimals, Delta Math doesn't want you to do that. So I say anytime you get a fraction, just make sure it's reduced. If it's reduced, leave it like that, even if whatever it is. Okay? Both of these answers can be okay. So on a test, I could ask you, what are the only 2 answers that I can't get that would be extraneous? What are the only 2 answers? 2 would be extraneous, right? What would be another one? 0, right? And I didn't get those. So I'm okay. 2 answers, 2 boxes. We're good. Okay. We're definitely going to do one more. If we have time, we'll do another one, but we're kind of running low on time. So if we don't have time, we'll do some for tomorrow. Okay. So let's do letter E. Okay. Letter E. Same thing. Common denominator. So common denominator is just going to be x plus 1. Distribute, and then combine like terms. So I get 2x plus 1 . Okay, so I'm going to stop right there for a little bit and just let everyone catch up, because the next step is going to be something we haven't seen yet. It's not bad, but we just haven't seen it before. So I just want to make sure everyone's, don't want to go too fast. Okay, so my next step is move the stuff I haven't used down. Right? They're not the same denominator. One is x plus 1, one has an x squared plus x. So again, could you use, yes, that would work. But let's try, since we've been doing it this way, since we've been doing it one way, let's keep it that way. Common denominators. Well, the first step for a common denominator is you got to make sure it's factored. The first guy is. I know this guy's factored because I did it earlier. This guy is not, the other guy is not factored. They didn't do that, so I have to factor it. It's a binomial. So binomial steps, GCF. What's the GCF? X. Yep. So when we, let me write it over here. So when I rewrite it, I get 2x plus 1, x plus 1. And then the other guy is 1, x on the outside, x plus 1. So it turns out they were pretty close. This guy just needs an x. Okay, now they're exactly the same. Denominators are exactly the same. Okay, so now let me write the denominator. X, 2x plus 1 equals 1. That's the top. Bottom's already the same, so I don't have to worry about that. Okay. Distribute. 2x squared plus 1x equals 1. Subtract 1 from both sides. Trinomial? Yep, already set it equal to 0. Doesn't have a GCF, so ABC. A is 2, B is 1, C is negative 1. Negative 2, positive 1. What are the two numbers that multiply to be negative 2 but add to be positive 1? Say 1, 1, negative 1. Yep, you guys got it. All right, so let's do the box now. The box is critically important. I know some of you are like, Mr. Flores, when I do this, I don't really need to use the box. And you're right. When A is 1, you really don't need to use the box, right? A lot of you can do it without. But when A is not 1, you have to. It's important to do that. So 2x, x plus 1 minus 1. If that happens, then you did something wrong somewhere else. Yeah. Or you have to use quadratic formula for that. It won't usually happen in this chapter because we're past quadratic, but it could happen. If it does, either you did something wrong up here or you just have to use quadratic formula, yeah. Okay, so separate and solve. Divide by 2. Get 1/2 for one answer. And -1 for another answer. Yeah, -1 doesn't work because it equals 0. So -1 would be extraneous. Solution. Okay, so actually we do have some time. We have 15 minutes. I'm going to give you one more problem. Okay, one more in your notes. You're going to do this one on your own. You're not going to wait for me. You're going to do it on your own and you'll be done. Okay, there we go. Okay, so I haven't finished the problem yet, but I at least did the first couple steps. Common denominator was x plus 1. Distributed. Brought down the side that I haven't used, and I stopped right there. Could distribute or cross multiplication work? Yeah, it could. But I think an easier way would just be making a common denominator. So the common denominator for these two guys is going to be x. X plus 6, x plus 1, x and x plus 1. I already have the x plus 1. I just needed an x. So you get x squared minus 4x plus 4 equals -2x squared. (3x squared minus 4x plus 4). Okay. Positive 4?
That's not a positive 4.
Which one's not a positive 4?
Right there. X squared minus 4x plus 4.
X
It's a
squared.
-4. When you distribute.
-4. Let's see.
When you distribute.
Oh, yeah. I see it now. This should be a -4. Thank you. When I distributed here and here, I forgot to change the sign to negative. So you get 12 and -4, which is going to be -6 and +2. Oh, I didn't change it again. So they're going to be 6 and negative 2.
No, so the
Wait.
two will still be the same.
Yes. Thank you. So we get 3x squared minus 6x positive 2x minus 4. Nope. Nope. Minus 2 plus 2. And separate and solve, you would get 2 answers. Negative 2/3 and positive 2.
Yeah.
And both answers would be okay. Yeah, let me finish this.
Positive 2/3. I'm positive.
Let's see. Minus 2 0. Okay. All right.